Okay, so the first most standard functions questions, you are just required to change x in the formula to the number 3 to find f of 3. So it's simple substitution, and if we do this, we reach the number 8. So f of 3 is 8. For g of 3, we have to locate the g function, change x to the number 3, and in this case we get something of a slightly nastier answer. But what's important here is that you're putting the number 3 into two different locations where x appears in both places in the g function. Do the full working out. Oh, let's not forget to okay, so there we go, 2 over 7. Okay, now next up we have using the f function again, only this time we're not putting 3 where x is, we're putting 2x plus 1. So the idea of replacing x with brackets is something we could use from the previous example and in this one. Only this time we are expanding brackets and simplifying rather than evaluating. So our answer will be an expression in algebra, 6x plus 2. Once again, we get a function with 2 copies of x in. What's important is that we leave brackets open for each copy of x. And then we put whatever is in the brackets after h into those brackets. And again, our answer will be in algebra. We have some brackets to expand, so let's write it out in full. The second bracket, since there's no number outside, I can just dissolve the brackets away. If I expand the double bracket, and then just leave the 2 extra terms on the end, and I gather them all together, I get x squared minus x. And that's the answer. Okay, evaluating compound functions. The important thing here is to put the brackets after the first letter and at the end. So I'll use colour to show those brackets going in. First thing we're going to do is find out what f of 2 is. We work from the inside out. So we find out what f of 2 is. Now that's just substituting 2 into our original formula for f, and that gives you 5. Now you've got a secondary problem, which is finding g of 5. So you're going to substitute 5 into the x position of the g function this time. And when you do that, you get 4 over 11. Okay, so the second example, we're putting brackets around g of minus 1, and we're calculating g of minus 1 first of all. Now let's go and do this up at the top away from where we're working at the moment. G of minus 1 is minus 1, take away 1, over 2 times minus 1 plus 1. So that's going to be minus 2 over minus 1. And that just equals the number 2. So we've evaluated g of minus 1. So we're going to change g of minus 1 into the number 2. And finally, we are evaluating h of 2 to finish the problem. We put 2 in the x position of the h function. And that gives us 6. Now, if we're asked to do the same thing with f of x, it's the same principle. We're changing f of x into what f of x is. Now, f of x is written at the top of your screen, and that tells us in the brackets we're replacing it with 3x minus 1. And this looks much more like a problem from the previous page now. So we're going to look at the h function, leave x out and brackets in, and replace inside the brackets 3x minus 1. We have brackets to expand and terms to gather. The second bracket, because there's nothing outside, it would just be the number 1, can be removed. Now when I gather terms, I'm left with 9x squared minus 3x. Okay, inverse functions. First of all, we look for the function f, and we make y equals f of x. And we write down our equation. We're going to change the subject so that x is the subject. And then we replace x with f to the minus 1 of x and y with x. So that's how we get our inverse function. It's the same each time, that process, that 3-step process. We'll try it again with g of x. We make y equal the function g of x. And we go through the process of changing the subject. We expand the brackets. And now we want to make x the subject. So we have to keep the x terms together and move everything else to the other side. So it becomes y plus 1 on one side and x minus 2xy on the other side. We take a factor of x out and divide through by the bracket. And now we replace x with g to the minus 1 of x and y with x. Okay, equation solving with functions. We replace g of x with the number 7. That's the idea. We're going to replace g of x with the number 7. And then we go on and solve that equation. We multiply through by the denominator as we so often do, expand the brackets, and solve. Take an x away from both sides and 7 away from both sides. And we're left with kind of a nasty solution, I guess, minus 8 over 13. For the next problem, we have to find the function g of f of x, because it's not given to us at the top of the page. We have to go and figure out what it is. So it's this idea of putting brackets around the inside function f of x. Looking for f of x, 3x minus 1. And now we're going to put 3x minus 1 into the function g. So we're going to write down the function g with brackets instead of x's and fill those brackets with the blue coloured algebra, 3x minus 1. If we expand and simplify, we get 3x minus 2 on the top. And our final step is to neaten up the denominator. There we go. Now, this function we've just found is g of f of x. So we're going to replace g of f of x with the function that we found, just as we did before, but we were given that function written down in the question. We had to go and figure out the function in this question. So now it's a case of solving the blue equation, multiplied by the denominator, and rearrange to find out what x is equal to. And x is equal to minus a third. Okay, key here is that our equation gives the y-coordinate as the value of f of x. So if we want to find f of minus 2, it's like we're finding y when x is minus 2. So we're going to use the graph, go to minus 2 on the x-axis, go up till we hit the curve, and go along and read off the y-axis. What is the y value at that point? And that's f of minus 2. That will tell you what f of minus 2 is. It's 13. If we want to find f of 0, we're going to make x equal 0. So we go to the x-axis, go up to the graph, and that point is 5, has a y-coordinate of 5. So f of 0 is 5. Finally, when x is 1, our y-coordinate is going to be 13. So f of 1 is 13.